we're going to do one more example where we need to find the orthogonal trajectories of the family of curves, and here's our family right now. Y equals y1 plus c1x over 1 minus c1x. So for more details, watch the introduction video and example 1. But we'll just go ahead and do the steps here a little bit quicker. Okay, so first we start by finding the corresponding differential equation, right? So for that we have to find derivative dy dx. Now the derivative of that quotient will be what? So we have to use the quotient rule. So according to the quotient rule, it's the expression from the numerator times the derivative of the expression from the denominator. So derivative of the denominator that's 0, and that's negative c1x, so just the constant, right, times negative c1 minus, then it's going to be the derivative of the numerator, which is just c1 times the expression from the denominator, 1 minus c1x, and then over the square of the original denominator, 1 minus c1x to the second power. That of course has to be simplified. Let's distribute negative c. It's going to be negative c1, right? Negative c1. So where's my red pen? Okay, I'll use green. I'm distributing here, and that c1 I will distribute. So negative c1 minus c1 squared x minus c1, and then plus c1 squared x. Okay, it looks like we have opposites here, right? Negative c1 squared x and then positive c1 squared x. That will go away. And we will have negative 2c1 over 1 minus c1x to the second power. Okay, so that is the derivative, but then in order to obtain the differential equation, we need to get rid of c1. We need to replace c1 with whatever it equals to based on the original equation. So for that, we will do some scratch work on the side. I'm gonna write down my original equation. Let's say, where did I write? Let's put it here. 1 equals 1 plus c1x over 1 minus c1x. So from here I need to get c1 by itself. So to do that, let's multiply both sides by the denominator. Right, so we're multiplying both sides by 1 minus c1x on the right and on the left. Now on the right hand side, I can divide out 1 minus c1x, and what I have is y times 1 minus c1x on the left, and then 1 plus c1x on the right. On the left, let's distribute y minus c1x, y equals 1 plus c1x. Okay, so why are we doing all that? Remember, we had to take all those steps so we can get c1 by itself. We simplified, cleared parentheses, and how do we get c1 by itself? So the very nice working trick is just to combine all terms, put together all terms involving c1, and then factor out c1. So in other words, I'm gonna put, let's see, I'm gonna add c1xy to the right, and then I'm gonna subtract 1 from both sides. So in other words, I'm gonna have y minus 1 on the left. I'm subtracting 1, right? And then I'm adding c1xy. So I have, let's see, c1x, that's what I have here on the right, plus c1xy. And then once you collect all terms involving variable that you want to get by itself on one side, you can just simply factor it out. So it's going to be c1 times x actually we can factor out c1x, right? Let's do it right away. So I mean, we could do it later, but let's do it right now. c1x, that's something that we can factor out. That's going to help us along the way. So it's 1 plus y, right? And then the left hand side is y minus 1. And what's left to do is just to divide. Okay, I'm going to move it up to divide by x times 1 plus y. Divide by x times 1 plus y on the right, and by that same thing on the left. That's gone, and here it is. I'll switch sides, or swap sides. C1 equals y minus 1 over x, it's 1 plus y. I'll write y plus 1 just to be consistent with the numerator. Okay, perfect. And that is something that we'll need to plug into our derivative. So our derivative, maybe I'll copy down the left hand side. So dy dx is currently that, right? So c1 is going to be replaced by this expression. For now it looks like too much, but I think quite a few things will simplify. Let's try. Okay, so dy dx equals -2 times, and here I'm multiplying by y minus 1 over x times y plus 1. Next, that's all over, and what's going on here inside the parentheses? It's going to be 1 minus c1. c1 is y minus 1 over x times y plus 1. That's c1, but that has to be multiplied by x times x to the second power. Okay, now the numerator, well, I'll multiply -2 by this fraction, so the numerator is -2 times y minus 1 over x times y plus 1, right? That's the numerator. And now the denominator, so I guess my equal sign is a little bit lower right here. The denominator is what? So I can see that x and that x would be cancelled. And I have 1 minus y minus 1 over y plus 1 to the second power. So that is the complex fraction, right? Fractions within the fraction. So remember, the way to simplify a complex fraction is to get down to just one fraction on the numerator. One fraction on the numerator, and then just one fraction on the denominator. So, which means that our next goal will be to combine everything in the denominator. So 1 I will write as 1 over 1, or I can think about it as 1 over 1. In order to combine it with the second expression, I have to multiply both top and the bottom here by y plus 1. So long story short, maybe I'll do it right here on the side. So that is same as y plus 1 over y plus 1 minus y minus 1, y plus 1, like that. And that is, so I have to be careful here because of the minus, y plus 1. I'm combining now, minus expression y minus 1, and I'm putting it inside the parentheses not to lose any signs. Now I will distribute negative, so it's y plus 1 minus y plus 1, okay, over y plus 1. So that's all inside the parentheses here. Now what do we see? We see that y's will cancel, and it's going to be 2. Okay, perfect. So that is, let me rewrite it. -2 times y minus 1 over x times y plus 1 over, and now we have 2 over y plus 1, but that's all to the second power, right? Okay, so I think we're ready to finish this complex fraction by rewriting that in using division operation, right? So we're going to take the numerator, -2 times y minus 1 over x times y plus 1, and we're going to divide, well, we are dividing by this denominator, but remember division is same as multiplication by the reciprocal. So reciprocal will be y plus 1 squared over 4, like that. And let's see what happens. So what happens is that y plus 1 and then one of those expressions will cancel. What else? 2 and 4, I can divide out 2, right? So that's 1 and that's 2. And that means that we're left with negative y minus 1 times y plus 1 over 2x. Okay, perfect. So putting this all together, let's refresh why we needed all that. Well, that was actually the differential equation that corresponds to the given family of curves, right? The family of curves. So first, to refresh, first we found the derivative, and then we replaced C1 with the appropriate expression from the original equation, right? And that's what we obtained. So here's that differential equation for our family of curves. Y plus 1 over 2x, right? I just rewrote it. Now, next, once we obtain this differential equation, now we're going to obtain differential equation for that other family of curves, the one that are going to be represent orthogonal trajectories, right? And that, to obtain that one, we'll use the idea of the negative reciprocal. So the negative reciprocal, so that differential equation will be reciprocal, so I'll flip that and I change the sign, so negative sign goes away. 2x over y minus 1 times y plus 1, like that. So these are negative reciprocal. And now we're looking at the differential equation that represents that other family of curves that we're trying to find. So how do we find it? Well, we find it by solving this differential equation. And again, this differential equation is a separable equation. We can easily put together everything involving y and everything involving x by using cross multiplication, right? So y minus 1 times y plus 1, well, that can be simplified as well, equals 2x dx. Or that's another place where we can apply the formula, right? Difference of two squares. That's same as y squared minus 1 dy equals 2x dx. And to solve that, we just simply integrate both sides. We integrate the left-hand side, we integrate the right-hand side. So the integral of y squared minus 1 is y cubed over 3 minus y plus, well, c2, right? Or plus c, I'm using c2 since our original family had c1. And the right hand side is 2x squared over 2, which we can simplify, so I'm going to rewrite it. Y cubed over 3 minus y plus c2 equals x squared. We can keep it like that, or we can put all terms on one side, but either way, that's going to represent the orthogonal trajectories. So that family of curves is representing the orthogonal trajectories, which means that you can pick any curve from this family, pick your favorite, use your favorite color, use your favorite number for C2 here, so pick a specific curve from this family and pick any curve from the original family, and as you check those curves, you'll find that they're orthogonal. In other words, they're tangent lines at the point of intersection of those two curves are perpendicular lines. So that's the answer here.